Welcome to my YouTube channel. In this video tutorial, we are going to discuss about the concepts of mathematics for GRE. In this particular video, we are going to discuss about the arithmetic, and in this particular topic, we are going to discuss about the concept of integers here. Here I will provide you variety of questions on which we are going to discuss, and with the help of these questions, all the concepts related to every topic is going to get clear. These are the best questions for the preparation of GRE. So let's get started. This is our question number 1. It states if n is an odd integer, which of the following must be odd? For this we have to understand the properties of odd. If you add, let us take an example, let us say 2 plus 3 is 5. That means an addition of an even number and odd number will give you an odd number itself, right? Similar way, 3 plus 3 is equal to 6. That means adding two odds will give you an even number. Also, 2 plus 2 is equal to 4. This is even, this is also even, will give you an even integer. So here we have to check as per the question what it states. If n is an odd integer, that means n is an odd integer, which one of the following must be an odd? So let's put some values here. Let's say n is an odd, n is 3. So 2 into 3 plus 3, 3 to the 6, 6 plus 3 is equal to 9. 9 is an odd number. Similar way, 2 to the 4, 4 plus 1 is 5, 5 is again an odd number. Similar way, 3 square plus 1 is equal to 10, which is an even number. 3 square minus 3, that is 9 minus 3 is equal to 6. This is again an even number. 3 3 is a 9, 9 plus 4 is 13. It's an odd number again. So here we have two options correct, right? A and D are the two correct options here. So we have more than one option correct type here. Now let's move towards the question number 2. Now what it states basically, let P and Q be the distinct prime numbers. Which of the following is a divisor of P square Q square? So P plus Q, that means let us say two prime numbers are 2 and 3. So 2 square into 3 square, number 1. So P plus Q, which is 2 plus 3 is 5. 5 is not a divisor of this one. Simple. P into Q. If we'll take factor from P square Q square, we will get PQ into PQ. That means 2 into 3 and 2 into 3. That means PQ is a factor. So answer is B here. So let's try it out. Other options as well. P square plus Q square, that is 2 square plus 3 square. 9 plus 4 is 13. This is not a factor of this itself. Similar way, P square Q cube is there. So you have to check the options as well. Here we can see that degree of Q is higher than this one. So obviously the product of this is greater than this one. So this answer will not be possible. So here we have only option B correct here. Now let's move towards our next question. So here question number 3 is the sum of the first 100 positive odd integers is this. So we have to find out what is the sum here. So sum of the first odd integers is basically n square. This is the basic formula of sum of first odd integers, positive odd integers. This comes from like 1, 3, 5, 7, 9 dot dot dot. Basically this is the sum of the AP formula, right? If you have studied about arithmetic progression, we are going to discuss this in our later sections, what is arithmetic progression, and we are going to discuss on that as well. So from there we got this formula n square. N is basically number of positive odd integers. Like here it is saying the sum of the first 100 positive odd integers, so n is 100 here. So simply we can say that 100 square will be the sum, that is 10,000 here. Very simple. So answer is C here. Now let's move towards our next question. Here it is saying if n is a positive integer divisible by 6 and 15. So what is the smallest possible value of n? This question is very easy. Always try to read the statement properly. If n is a positive integer which is divisible by 6 and 15. So what we have to do? We have to take the LCM of these two numbers. So C3, 5, 5 to the 10, 3, 30. So 30 is a positive integer which is divisible by 6 and 15. So option number A is correct. Now let's move towards our next question. So it states how many integers between 1 and 100 are divisible by both 3 and 5. Always remember that if any integer is divisible by 3 and 5, that means it should be divisible by 15 only. So we have to find those numbers which are divisible by 15 from 1 to 100, that means in between from 1 to 100. So first number will be like this form, okay, 15k, where k is equal to 1 2 3 4 dot dot dot. So while we are putting the values of k 1 2 3 4, the product should be less than 100 here. So first number will be obviously 15, then second one is 30, then it will 45, then it is 15 4 60, 15 5 75, 15 6 are 90. After that it is going to be more than 100. So we have to stop here. So how many numbers are there? 1 2 3 4 5 6. So 6 numbers are there between 1 and 100 which are divisible by both 3 and 5 here. Now let's move towards our next question. So here we have a number n is such that n square plus 4 is a prime number. Which of the following values can n take here? That means the resultant of this n square plus 4 should be a prime number. So let's plug in the values of n here. Let us say n is 1, then 1 square plus 4 is equal to 5, which is a prime number. Again 2 square plus 4 is equal to 8. This is not a prime number. 3 square plus 4 is 13. 13 is also a prime number. 5 square plus 4, which is 29. 29 again is a prime number. So we have multiple options correct here. So we can say a number n is such that n square plus 4 is a prime number. Which of the following values can n take? 1, 3 and 5 values can n take. 2 is not the correct answer here. So we have 3 options correct. Now let's move towards our next question. Here it states the product of the 3 consecutive integers is divisible by which number? So let's say we have 3 consecutive integers like n, n plus 1 and n plus 2. These are the 3 consecutive integers here. So we have to check that the product of these 3 consecutive integers is divisible by which number. Let's plug in the values of n. Let us say n is 1. So if n is 1, then 1 into 1 plus 1 into 1 plus 2. So we have 1 into 2 into 3. So here we can say that any input value of n, we are going to get some multiple of 2 or 3 here, right? So in this case we can say the product of 3 consecutive integers is always divisible by 3 and 6 here. We can't say something about 9 and 12 because these are the least value of n here. The product of 3 consecutive integers, so it should be applicable to all the values of n here. So we have substituted the least value of n, which is 1 here. So we can say our answer may be 3 and 6 as well. So we have 2 options correct here. Now let's move towards our next question here. Now this question is which of the following cannot be the sum of 3 consecutive integers? Here we have n minus 1, let us say n, then n plus 1. These are the 3 consecutive, it's some of the 3 consecutive integers we have. So if we add these consecutive integers, what we are going to get is 3 and only. That means any number which is a multiple of 3 will be the sum of the 3 consecutive integers here. So here we have 15, 18, 21, 26 is not the multiple of 3. So question is which of the following cannot be? So you have to read the statement carefully. Sometimes during exam students can do such mistakes here. So which of the following cannot be the sum? So obviously 26 is our answer here. Now let's move towards our next question. So this question is quite interesting. Here it states if n is a positive integer such that n factorial ends with exactly 10 zeros. That means once you expand the n factorial, then there should be 10 zeros in it. What it implies basically, in 100 we have 2 zeros. If we write 25,000, then we have 3 zeros like this. So we have to find n It states we have to find a positive integer n such that n factorial ends with exactly 10 zeros. So here we have a very good formula or very good concept here. What it states, let us understand with some other example here. Let us say we have to find number of zeros in 100 factorial. So here the concept is, always remember that the multiple of 5 gives you a 0 always, right? So what we have to do, we have to use this number in the floor function. We have to write this way, okay? The number of zeros in that particular number in which we are searching or in which we are finding basically. So you have to write 100 first, then you have to write 5, then plus again you have to write 100, then the next factor or next power of 5 is 5 square. So we have to increase the power, like 5 into 5 is 25 here, then again plus, then you have to write 100 upon 125. That's it, right? Obviously now we have to divide these numbers, and this is the greatest integer function, or you can say floor function. So once 100 is divided by 5, you will get 20, which is an integer. Now add this number 25. 100 divided by 25 is 4 here, and here you are not going to get any number integral value, so you can write simply 0. So 20 plus 4 is equal to 24. That means when you expand this 100 factorial, you are going to get 24 zeros in that particular number. So this is the basic concept which we are going to apply in this particular question. So at last we can say that 20 plus 4 is equal to 24 here. So simply we are getting our result, like after expanding 100 factorial, we are going to get 24 zeros here. Now let's apply this concept in our question here. Actually we require 10 zeros, so we have to try different numbers. Let us say, let's try with 40. So if we divide 40 divided by 5 with the greatest integer plus 40 divided by 5, 25, sorry, plus obviously the next number will be 0 only. So 40 divided by 5 is 8. 8 plus 1, we are going to get 1 here, obviously, because it is going to give us only integral value due to this floor function here. So again 8 plus 1 is 9. So we are getting the 9 zeros when we expand this 40 factorial here. Now next number is our 45. So 45, again we are going to try this. 45 divided by 5 plus 45 divided by 25 here. So 145 divided by 5 will give you 9. Here you are going to get 1. So 10. So our requirement is 10 only. So the question states n is a positive integer so that n factorial ends with exactly 10 zeros. So we are getting the 10 zeros when we are going to expand this. 45 factorial is going to give you 10 zeros after expansion. So I hope this concept is clear, and very interesting concept it is. Our next question is, a number is divisible by 12 if and only if. We have 4 options. It is divisible by 3 and 4, 4 and 6, 6 and 9. So obviously if we take the LCM of 12, then we are getting this. Okay, and the least number by which we can divide 12 is 4 into 3, or we can say 2 into 6 as well, but this is not feasible and this is also not available in our options. So we only have in the options like 4 into 3. So 3 into 3 and 4 are the numbers which divides 12 always. So a number is divisible by 12 if and only if it is divisible by 3 and 4. So our option A is the correct answer here. So let's move forward towards our next question. It states if A and B are integers such that A is greater than B is greater than 0. So in such cases you have to assume the values like this so that it should satisfy all the values, right? Now let us consider A is greater than B. If we take A is equal to 5 and B is equal to 2, let us say. So it is saying which of the following is the greatest common divisor of A and B. So is it B? Obviously in 5 and 2 there is not even a single factor available here. Now we have to take b minus 1. So let us say 2 minus 1 is 1. So 1 is a factor, but whether it is applicable to other numbers as well. So let us assume b is equal to 4 here, or b is equal to 3 here, right? So b minus 1, if we take b minus 1, that is 4 minus 1 is equal to 3. 3 and 5, if we check, then we will find that there is no common factor in them. So this is also false. Both these statements are false. Now let us consider a minus b. So 5 minus 2 is equal to 3. So if we take a 5 and b 2, then 3 is not our answer here. So this statement is also false. Now the options left is D, that is none of the above. So in this case, we got our answer option number D. Now let's move towards our next question here. It is stating that let n be a positive integer such that n square plus n plus 41 is a prime number. So result of this is basically a prime number. Now it is stating for how many positive integers is this true. Means we have to find how many positive integers are there where this statement is true. For this we have to put the values of n like this. N is equal to 2, n is equal to 3, like that. So let us assume n is equal to 1. So we will get 1 square plus 1 plus 41. So it will give you 43, which is a prime number. Similar way, if we put 2 here, then we will get 2 square plus 2 plus 41, which is 43 plus 4 is 47. This is again a prime number. Now if we put n is equal to 3, it will give us 9 plus 3 plus 41. So this is again a prime number. Now as per our options, let us check which option will give us the answer here. So in such a questions you have to put the values of n here. So let us say that if n is 40, let us put n is equal to 40. So what we will get here? So 40 square plus 40 plus 41. So you will get what? 81 here. 81 plus 40 square is 1600. So 1600 is basically nothing but 1681, and 1681 is nothing but it is a multiple of 41 into 41, right? The product of 41 into 41 will give you 1681. Then we can say that it is not a prime number. So our option is 39 here straight away, because we have already checked that by putting the value of n is equal to 40, we are not getting a prime number. That means till 39 we will be getting the prime numbers here. That means till n is equal to 39 we are going to get the prime numbers here. So our answer will be 39 here. So for how many positive integers is it true? It is true for 39 positive integers, that is values of n. Now let's move forward and discuss our next question here. It is saying if x and y are integers such that x plus y is odd, which of the following must be true? So we have already discussed this concept earlier. Now we know that if, let us take an example of 2 and 3. Okay, if both x and y are odd, if one is odd and another one, this is even, this is odd, it will give you a result of odd. X and y are odd. If both are odd, 3 plus 3, it will give you an even number. So this is not true. One of x or y is odd and other is even. This is the true value here, true answer here, because it is stating that if x and y are integers, other x, y is odd. So we have to find the result as an odd. So option B is correct, because if both x and y are even, then the value is even, and x is odd, y is even. It will also give you the result here. So we have two options correct here, B and D here. Now let's move towards our next question. Our next question is if n is a prime number greater than 2, then which of the following is always true? That means if n is a prime number which is greater than 2, which of the following is always true? It is stating that n is even. So if n is greater than 2, and n is a prime number. So 3 is a prime number itself. So we can say n is even. No, it is false. Similar way, n is odd. So prime numbers greater than 2 are 3, 5, 7, like that. So these are odd numbers here as well. And it is stating that C, n is divisible by 3. If n is 3, then it is true in this particular case. That means if n is equal to 3, then the statement C is valid. Otherwise, for n greater than 3, it is not valid, as we are getting 5 and 7, which is not divisible by 3. Similarly, n is divisible by 5 is also false. So we have our option number B is correct. Now let's move towards our next question here. It is stating how many positive divisors does 360 have. For this, we have to take the LCM first. Let us take this way, as we need to find the powers, that is exponents of each factor here. So this is the case here, right? So we got all the factors here. As we can see, we got our factors here. So we can write it this way: 2 raised to the power 3 into 5 raised to the power 1 into 3 raised to the power 2. So whenever you got such questions, how many positive divisors of a number, then you have to find the LCM first and write the numbers this way. Now we have to use the divisor formula here, which states that number of divisors is equal to p raised to the power e1 into p1 p2 raised to the power e2 into p3 raised to the power e3, and so on. So here, if we compare, p1 is like 2 and p2 is 5 and p3 is 3, right? So after that, it states the divisor will be e1 plus 1 into e2 plus 2 into e3 plus, sorry, 1 here, 1 here, right? So here we have to write e1, that is e1 is equal to 3 here. So 3 plus 1 into 1 plus 1 into 2 plus 1. So it will give you 3 plus 1 is 4, 4 into 2 into 3, which is 24 here. So we can say the number of positive divisors of 360 are 24 here. We can easily see that the number of divisors are 24 here. So this is basically the divisor formula, which states e1 plus 1, e2 plus 1 into e3 plus 1. These are the exponential, or you can say the powers of our prime factors here. So I hope this concept is clear now. Let's move towards our next question. Here the question is, where is the LCM, least common multiple of 8, 9, 12? So we can easily find the LCM of these numbers. Simply you can write six is a 18, 18 for 72. So we have 72 here. So this question was very simple. Now let's move towards our next question. So this is our next question. This is quite interesting. If x and y are positive integers such that this x square minus y square is equal to 60, then what is x plus y? So let's do one thing. Let's take out the factors here by using a square minus b square, which is a minus b into a plus b is equal to 60, right? Now let us take x minus y is equal to a and x plus y is equal to b here. So we got two values here by assumption, like x minus y is equal to a and x plus y is equal to b. Now what we require is basically a into b is equal to 60 here. Now what we have to do, we have to make pairs of a and b by assumption, like 1 into 60. 1 into 60 will give you 60. Similarly, 2 into 30, it will give you 60. We can take these factors by doing LCM as well. Similarly, 3 into 20 is equal to 60 and 4 into 15 is equal to 60 and 5 into 12 is equal to 60 and 6 into 10 is equal to 60 here. Now, what we can do, we can solve these equations by using pairs. Like first pair is 160, another pair is 230, like this. So we have two equations like x plus y is equal to 1 for the first one and x minus y is equal to 60 here. So once we add these equations and if we subtract these equations, what we are going to get is basically 2x equals to sum p plus q, we can say, and x equals to p plus q by 2, right? Similarly, if we subtract these equations, we are going to get minus 2y is equal to p minus q, like this, right? Or we can say y is equal to q minus p upon 2. In this manner, we can easily find x and y. So what we can do, we can simply erase this one. And specifically, if we check these numbers, these two numbers should be even to get our result even, otherwise it should be odd numbers. So in this case, we can easily see that 1 and 60 will give you 61 and 2x equals to 61 will give you some decimal number here, 30 point something. So we have to ignore such numbers. In this case, like 2 and 30, we are going to get some values here obviously. Then 2x equals to 32 and x equals to 16 here. Similarly, if we subtract these two numbers, we are going to get y is equal to 30 minus 2, 28. 28 divided by 2 is 14. So we got our first pair of integral value, that is 16 and 14 here. And now it is saying that x plus y is what? So we have these results here available. So obviously if we are going to add 16 plus 14, we are going to get 30 and there is no such options available here. So we have to do more calculations here. So let's erase here. Similarly, we can check the pairs which are even here. So we got our pairs like 3 into 20, which is not possible obviously. It is going to give you odd number. Similarly, 4 into 15 is an odd number here. And 5, 12, this is also an odd number. Now we got 6 and 10 here. We can try this out. So 2x equals to 16. By putting 6 and 10 here, right? So 2x, by adding these two equations, you are going to get x equals to 8. Similarly, if you subtract these, you will get minus 2y is equal to 6 and 10, that is minus 4 here. So you are going to get y is equal to 2. So you are having numbers x equal to 8 and y is equal to 2. By adding these two numbers, you are going to get the result, which is 10 here. So our option number B is correct here. So what is the value of x plus y? It is 10 here. So I think this concept is also clear to you. These questions are frequently asked in GRE. Now let's move towards our next question. Now our next question is, if n is divisible by 36 and 48, so what is the smallest value of n? So n is a number which is divisible by both 36 and 48. That means we have to find the LCM of these two numbers. So let us do this way. 36 and 48 is 6, 6, 38, 6, 8, then 2, 3, 2, 4. Now 4, 3 is a 12, 12 2 is a 24, 24 into 6 we can do 144. So 144 is our answer here. That means 144 is the smallest number which is divisible by 36 and 48 both. So B is our option here. Now let's move forward towards our next question. It states if A is a multiple of 3 and B is a multiple of 4 and A plus B is odd. So what is A into B divisible by? So question is quite clear. If A is a multiple of 3 and B is a multiple of 4 and A plus B is odd. So what is A into B divisible by? Now if A is a multiple of 3, that means A should be in the form of 3k, and B is a multiple of 4, that means B should be in the form of 4m here. And A plus B is odd. If A plus B is odd, that means A is odd and B is even, because we have B is a multiple of 4 here, that's why B is always even, and A is a multiple of 3. We can also get even number by multiplying 3 with 2 and 4, etc. But to get an odd value of A plus B, we should have one odd and one even here. Now it states that what is A into B divisible by? Now if we multiply A into B, we are going to get this way 3k into 4m, which is 12km here. 12km here. So this implies that whatever the value of k and m here, we have a 12 here. That means every number of this form, that is 12km, should be divisible by 12 here. So we can say that A into B is always divisible by 12. I think the concept is clear now. Now let's move forward towards our next question. So this is our next question, which is quite simple. We can say if n is a positive integer such that n square minus 1 is divisible by 24. So what is the smallest possible value of n? In these cases, you can simply plug in these values here. Let us take first example like 5. If you put 5 square minus 1, which is 24 only, it is going to give you the result here. And 5 is the smallest number here. So what is the smallest possible value of n? It is 5. We need not to do these multiplication here unnecessary. Otherwise, it is going to waste your time in examination. I hope the concepts of integers are now clear to you. We are also discussing this concept in our next video, in which we are going to discuss more problems in more detail that will enhance your skill and will help you in preparing the GRE Quant section. If you follow this GRE Quant tutorial, you need not to worry about your score. You will feel confident and you will get maximum score in the GRE Quant section. We are going to discuss more problems in our next video. Till then, goodbye and God bless you always.